We have seen that if there is a transmission line of characteristic impedance Z0 and having a phase constant beta, the length of L, which gives an electrical length of beta L, irrespective of the length of the line, if the source and load impedance are equal to the characteristic impedance of the line, the looking in impedance is going to be Z0 either from the source side or from the load side. And this is a very important property because it allows us to design systems with a known looking in impedance without worrying about the length of the line. Now the question comes is, if we choose a reference impedance Z0 such that all the load and sources as well as the transmission line is designed for a given known reference impedance. So what should be the optimum choice of such a reference impedance? So the choice of reference impedance mainly gets decided by what are the properties of the transmission line. So this transmission line traditionally was realized with the help of coaxial cable. The coaxial cable construction was having a metal shield around it, and in the center there was a conductor. So as you understand, we need two pair of conductors, and in between the material was filled with a dielectric element. Here it is one conductor acts like a shield. At the center also there is a solid conductor. And in between this space is filled with dielectric material. So when we have to choose a value of a reference impedance, mainly this gets decided by the way the this transmission line is constructed. And here we can see that Z0 will depend on spacing between the center conductor and the outer conductor and the dielectric constant of the material in between the two conductors. We can think of first trying to choose as high value of reference impedance as possible. The reason being, if the reference impedance is very high, then even though there may be a small loss in the this coaxial cable, the overall attenuation in the system is going to be low. So this is coaxial cable. Idea is, if you, let's say, choose Z0 to be very high, for the time being, I'm just assuming there is a small resistance in the wire which is connecting the source to a load, which is also at Z0 value. This R loss. You can see that in such a simple circuit, if the Z0 value is increased, then we can see that for a given small loss in the cable, the overall attenuation is going to be minimized. Because this VO is VS Z0 by 2 Z0 plus RS. Okay. It implies high Z0 minimizes attenuation of signal. Okay. Is there any downside of choosing high Z0? We can see that if the Z0 is chosen to be very high value, then for the same amount of power which is going to be delivered, we need to apply much higher voltage. Assuming Z0 is chosen to be a really high value, such that the loss in the line is not significant, then we can see a circuit which becomes like this. And if I look at the power which is received by the load, it is going to be equal to Vs square divided by, here we can see 4 Z0. If we increase the value of Z0, we can see that for the same power, Vs also needs to be increased. And if we increase the Vs value, when the signal is going to flow through a transmission line, there is going to be very high electric field between the two conductors. There will be a limit which will come, which we will realize at which this dielectric may break down. We can see that if we want to transfer as high power as possible to the load without the breakdown of the cable, then the Z0 value which we are choosing as a reference impedance should be as low as possible. Allows higher power to be delivered to the load without dielectric breakdown of transmission line which is being used. So to minimize attenuation, Z0 should be high, whereas for high power to be transferred to the load, Z0 should be low. So traditionally, these coaxial cables were being used, and it turned out that Z0 is equal to 50 ohm is a good trade-off between attenuation and breakdown. And this was true for the specific kind of material being used earlier. And once the reference impedance has been chosen to be 50 ohms, then it has been continued, and even now we are using the same reference impedance.